Alright, welcome back to another video on my channel, math_exe, and today we're going to look at another type of exam type question involving linear inequalities. And this one is a little bit tricky, but I'll just try my best to explain. So we're given that x is between 3 and 5, and this is including 3 and 5 because we have a less than or equal to sign. That means x can be either 3 or 5 as well. And same for y right here. Y is between -2 and 4, including -2 and 4. And we're given also that x and y must be integers. Okay, so first part A, we're going to find the maximum value possible of x minus y given these intervals right here. And next we're going to find the minimum value of this expression, x squared plus y squared. Okay, so we're going to do the A part first. So let's see, I'm just going to write in blue, solve A. Now the thing is, if you want to approach a maximum value of x minus y, we must have x to be the maximum and y must be a minimum. And you can use logical thinking to do this. I mean, think about it. If you have like something great as 1,000 and something as less as just 0 point something, 0.1, and this will be still pretty big. So yeah, 9999.9. Yeah. So that's the whole point of this. And notice that y can also be negative, and the more small the y value is, or the more bigger the x value is, the larger the expression x minus y will be. So yeah, so all we need to do is to choose the biggest value of x and the smallest value of y. So in this case, we're going to pick x is equal to 5 and y is equal to -2. So what we're left with is 5 minus -2, which is just +7, and this is the maximum value. So to find the minimum value of the second part, we must look at the ranges of a quadratic function, I guess. But in case you haven't learned about quadratic functions yet, you can just simply notice that the expression x squared is always bigger than 0, or sometimes could be equal to 0, and it's possible when x is equal to 0. Same thing for y right here. So what this tells us is we need to find a value we need to find some values of x and y that are very close to 0 or close to 0 as possible. So in this case, I'm just going to erase our choices right here. What we're going to do is we're going to choose our x value to be the closest integer to 0 given these intervals, which is 3. And for our y value, since 0 is also included, so why not just include 0 and in here. So what we're left with is the minimum value of x squared plus y squared is equal to 3 squared plus 0 squared, which is just +9. And this is the answer. And it looks pretty tricky at the first, but you can just do some practice, which I'm going to show you some examples of. So let's jump into the next example. Okay, so this is the second example. So given these intervals, x is between -10 and 10, including -10 and 10. Y is between 0 and 5. However, this is excluding 0 because this is a strict inequality. So this is completely greater than 0, and it cannot be equal to 0. However, it includes 5 in this interval. So in other words, y is between 0 and 5, not including 0 but including 5, and given they are integers as well. So first we're going to find the minimum value of x squared times y, and next we're going to find the maximum value of x over y, and then next we're going to find the minimum value of x squared minus y to the fourth. Okay, so for the first part we're going to solve the minimum value of this. Okay, so for this to be negative, since we know that x squared is always positive, or sometimes it could be equal to 0, we must have y to be negative. However, there are no negative values inside this interval, so we have no choice to just pick the smallest positive option. And notice this is not 0 because 0 does not lie in this interval. However, it's the next integer, which is 1. And for x squared, you can just take 0, because if we take like something like negative 10 and we have 100, and then 100 times 1, which is, I would say, not really the minimum value, but however x equals 0 does lie in this interval, and you might just guess this is equal to 0 squared times 1, which is just 0 right there. Okay, so for the maximum of x over y, we need to choose an x value which is maximum and y value which is minimum. I mean, if you think about it, if we like divide something relatively big to a relatively small number, like so, the result will be very, very big. So you can just count this, you can just get 1 million right there. So this is just an example. So we're going to pick the maximum value of x possible in here. I'll just rewrite the question real quick. Maximum of x over y. So we're going to pick x is equal to 10, positive 10, and y is as small as possible. However, we cannot choose 0 because it is a strict inequality. We can just choose 1 instead. So we're left with 10 over 1 is equal to 10. Alright, for the next part, we're going to solve for the minimum value of this. And when you're dealing with subtractions, you must consider this to be the maximum and this to be the minimum. And however, notice this cannot be negative because the range of any like even powers is always positive, and I just mentioned right here. So you can just try it yourself if you didn't understand what I'm talking about. So if you have like something to the second power, or something to the fourth power, or something to the sixth power, and so on, all the even powers, you'll notice that every single input will get a positive output, and it could sometimes be 0. So what we can do is to choose a y value that is the smallest positive value possible, and then we'll have to choose a maximum value of x. So in this case, we're going to choose a maximum value of x which is positive 10. So we have positive 10 squared minus our minimum positive y value, which is positive 1. And we know this 1 to the fourth power. And then you can just manipulate this to get a final result of 99. I'll do another example, a last example of this type of question. Alright, and for the last example, we're given, instead of 2, we have 3 variables right here. So A is between 3 and 8, including 3 and 8. B is in between 2 and 12, including 2 and 12. C is between -2 and 2, including -2 and 2. Okay, so for the first part, we're going to find the maximum of A, B, C. And next, we're going to find the minimum of A, B over C. And finally, we're going to find minimum of A minus B plus C. So if you encounter something that looks a little bit like this, where you have like more than two variables in given specific intervals, well, you can just do the same trick as we did in the last examples. So for the A part, we can have A, B, C, and we can either choose A to be max, the maximum possible value, B is the maximum possible value, and C be the maximum possible value, or we can just choose two. We can just choose two of them to be the minimum, or I shouldn't say minimum, something that is less than 0 and is at the minimum point, and minimum, and this is less than 0. B is at the minimum and less than 0, and C is equal to max. And notice you can just switch some variables up and you can just test them up. However, we only have one variable which has a negative value in its interval, and if we substitute that in, we will end up with a minimum value. So we don't want that to happen. So instead, we're going to choose all to be positive and maximum. So I'll just write maximum of A, B, C is equal to, the maximum A is 8 times maximum of B is 12, and maximum of C is 2. And you can just count this. 8 times 12 is 96 times 2, which is 192. There we go. Okay, for the B part, I'm going to find the minimum value of A, B over C. And as we knew before, C is the only variable that contains a negative value right here. But this gives us a clue, because if we choose the -2, if we choose a -2 right here, it gives us a negative value, and then we can just choose A and B to be maximum, and then therefore we get the minimum value. So that's just a trick to encounter that. So we choose the maximum of A, which is 8, times maximum of B, which is 12, and over the minimum and negative value of C is 12, -2, sorry. Okay, and we're left with an answer of -48, and this is the answer. Okay, for the next and the last part, we're going to find the minimum of A minus B plus C. Okay, so as we all know, we can just choose in some subtraction, and then we want to find the minimum. In this case, we need to consider A to be the minimum and B to be the maximum. And if this were to be, we need to find the maximum, we need to just switch things up. We need to find A maximum, B minimum. And how about the C? Well, C must be a minimum, because if we add things up and then we add if this was the maximum, we're going to have a pretty high value, which is not what we want. However, C can also be negative because of our interval right here. We have negative 2. So therefore we can just clean things up. So we have our minimum of A, which is 3, maximum of B, which is 12, and minimum of C, which is negative 2. And you can just manipulate this to get negative 11. There we go. And I will just consider doing more examples in the future because this looks pretty tricky to some beginner students. And hopefully guys you enjoyed this video. Please subscribe for more and I'll see you guys in another video. Bye bye.